A relation is a set of ordered pairs, and it can be represented by a list of ordered pairs right here, or a graph, or a mapping, which we'll do down in example 2. And a function is a special type of relation where each x value has one unique y value. So the domain are the x values, and the range are the y values. So for example 1, graph the relation, and then, so I'm going to graph the ordered pairs -1, 4, 3, 4, -1, 6, 2, 6. Okay, so is this a function? No, it's not, because this -1 can't go with 4 and 6. So no, -1 is repeated. Or it does not have a unique y, it has two different y values. That's another way that you could describe it. So the domain, they're all the x values. You want to write it in set notation, so I'm going to use one of these brackets, and I'm going to always write my domain from least to greatest and not repeat any numbers. So it's -1, 2, 3. Same with range. I'm going to write the least y value is 4 and then 6 and close the bracket. To create a mapping, what you do is you write your inputs. So I list off my x's and my domain right here, which is -1, 2, and 3. And I list the range, 4 to 6. And I actually show the connection between each x value and the y value. So -1 goes with 4, 3 goes with 4, -1 goes with 6, and 2 goes with 6. So you can tell it's not a function either, because -1 is going to two different numbers. It doesn't matter that the 4 is repeated or the 6 is repeating. It only matters that the x is repeating up here. So determine whether the mapping is a function. Yes, it is. Yes, because each x has one unique y. And then the vertical line test. The vertical line test means that if you draw a vertical line, so if this is your xy coordinate plane and you have a function, if you draw a vertical line, infinite number of vertical lines, it will not cross, it only cross once. The vertical lines would only cross at most one time the red relationship. If that is the case, that is a function. So I'm just going to show you examples. If these are my coordinate planes, this would not be a function because I could draw a vertical line and it would cross twice. This would be a function because I could draw vertical lines and it would only cross once. This would not be a function. No, because if I draw vertical lines, it crosses twice. This would not be a function because if I drew a vertical line, it would cross 3 times right there. But this would be a function because if I drew vertical lines, it wouldn't cross twice. So I'm going to do a few more of these practice. So if I draw a vertical line, it crosses twice. So no, yes, no, because it's crossing these two ordered pairs twice. And then we also have function notation. So we did this in Algebra 1. So if you have y equals, y is your output and x is your input. Y is your dependent variable and x is your independent variable, because the y depends on what you plug in for x. So another way that we can write our independent and dependent variable or output, our input, is f of x. So f of x, this is read f of x. This means that if you have f of -1, it means that you're going to replace your x or your independent variable with -1. So I'm going to write f of -1. So you do want to use this notation. and plug in 1/3 times -1 plus a half. So this is going to be -1/3 plus a half. Then I want to get a common denominator, which is 6. So this is -2/6 plus 3/6. So that's 1/6 is the answer. Now likewise, I'm going to do f of -3. So I do f of -3 equals 1/3 times -3 plus a half. So if you have 1/3 of 3, that's just going to be 1, and so that's going to be -1. So it's going to be -1 plus a half, which is -1/2. And I could do the same thing for 6 as well. I could plug 6 in. But I'm going to skip it and go to -4 times f of 1. So this means that you need to do f of 1 and multiply it by -4. So f of 1 is, look at my function again, 1/3. So 1/3 times 1 plus a half. So f of 1, so that's 1/3 plus a half. I'm going to get a common denominator of 6, so it's 2/6 plus 3/6, which is 5/6. But then I'm going to multiply -4 times 5/6. So this is -20/6, which is -10/3 is my answer. And you can use functions with word problems too. So the function for a bank account's balance B for an account starting with $100 earning an interest rate of 4% and left untouched for n years can be calculated as B of n equals 100 times 1 plus 0.04 to the nth power. Calculate B of 0, and what does it represent? So this independent variable stands for n, which is years. So 0, this means 0 years, or initial amount. So it represents the initial amount that you're plugging in. So if I plug in 0 for n, this is going to be 100 times 1.04 to the 0. So anything to the 0 power is 1. So this is going to be 100, which I know anyway because that's how much money you put in. And then if I do B of 15, that represents 15 years. So I'm going to plug in 15. Okay, and you can put this in your calculator, and then I would round to 2 decimal places. Because we're talking about money, you always want to have 2 decimal places. You can also find domain and range from functions that are more than just ordered pairs. So when you're finding the domain, you want to look at your function going left and right. So the domain is, if this function is going infinitely to the left, so it doesn't start, it's starting at -infinity, because it's going infinitely to the left. So I'm going to write -infinity, but then it keeps going to the right. So this is going to +infinity. In my range, it's stopping at 2. It's going straight across at 2. So range, you want to look up and down, and it's starting at -1. So the range is contained between, I didn't draw that very well, but it's contained between -1 and 2. So it's starting at -1 and going up to 2, and it includes those two. Okay, second one, the domain, remember, is going left and right. So there's no values in this relation over here. So the first x value starts on the x-axis, it starts at 0, and it goes infinitely to the right. So it includes 0 and goes infinitely to the right. So it's 0 to infinity. And then the range, see how it's slanted down with the arrow? That means that it would just go on forever down. So it's starting at -infinity, and it's going up to +infinity. Because also this is going up and up and up and up. Okay, the domain for the second one, remember domain, look left and right. it keeps going infinitely to the left, and it keeps going infinitely to the right. So that is going to be negative infinity to infinity. And then the range, it doesn't start until this point right here. So the first y value is starting at 2. And it's going infinitely up because this is going infinitely up. So it's starting at 2 and going to infinity. So these so far have all been continuous functions. So a continuous function is when I can trace it and my pencil stays on the paper. So this would be continuous, this would be continuous, this would be continuous, this would be continuous, this would not be continuous because I'd have to jump up. So this domain right here, what you want to do is look left and right. So technically this keeps going to the left. This keeps going to the right. So it's negative infinity to infinity. But the first y value for the range up and down doesn't start until negative 4. So it goes from negative and 4, and it keeps going infinitely up to infinity. Over here, the domain, it's going infinitely to the left and right, so it's negative infinity to infinity. And then the range, it's going infinitely down, infinitely up, so that's also negative infinity to infinity. This is a discrete function. It's just dots, okay? So for the domain, I can actually list the ordered pairs. So this ordered pair is negative 3, 4. This ordered pair is negative 3, 0. This ordered pair is negative 3, negative 4. So I'm just going to list out the domain is negative 3, and the range is negative 4, 0, 4. Because remember, you want to list the range and domain in order from least to greatest. So this has nothing with infinity because these are just ordered pairs. Okay? Over here, these other functions are sets or relationships, are infinite ordered pairs. So that's why we had to use this interval notation. Okay, this domain is starting, or this function, actually it's not a function, this relationship, is going left and right from negative 5 to 5 and including it. And the range is going up and down from negative 2 to 2 and including it. This domain right here is going infinitely to the left ever so slightly and infinitely to the right ever so slightly. So it's still negative infinity to infinity. And it's starting down and going up infinitely. And this last one, the domain, it's going infinitely to the left, infinitely to the right. So that's going to be negative infinity to infinity. And the range is only negative 2. There's no other numbers for the y. So the range is just the number, negative 2. So actually, you could write it using interval notation like this, or you could use the set, negative 2.